All right, here we go. We're going to do 0 to 1 inch. We're going to do 3 of them and then average them. Or you guys are going to average them. You're going to get the numbers, you're going to average them, and then that's how you're going to fill out your lab. So here's our first one, 0 to 1 inch. I think these are from section 4. Not that it really matters. All right, so we got a peak of 70,897. That's all right. Go ahead. All right, sample number 2. $77,689.
It looks like it's 0 to 1.
Right.
That's enough. Yeah.
All right, this is our third sample. As you can see, it actually looks like a 0 to 1, where there's a lot more porous on the sides, didn't fill out near the container, the outer edge of the container.
Which means our mix wasn't very good.
It means we didn't have a very good homogeneous mixture in our wheelbarrow. That's typically what we'd see for a 0 to 1 inch, somewhere between 30 and 45,000. All right, next we're going to do our 1.5 to 3. These are actually, does it give the actual slump on the cap? These are actually 1.5 inch slump. Okay. And if we look at the sides of it, you can see it's a lot smoother than that last one that we did.
Good.
All right, 58,629.
I got them right here. These are the new set of tabs on the shelf in there. Not in there, but next refrigerator.
All right, sample number 2 for 0 to 1 inch, actually 1.5 inch slump is what they had written on it.
This is breaking up. It wasn't even.
Yeah, this one was not even on the top, so it kind of knocked the corner off where it was uneven. So we're gonna let it go a little further. All right, so this one we're gonna do fracture the top cone. And we got 63,376, which is that's closer to the number we'd actually expect. We're using Crete 5000, 4-inch diameter cylinder, gives us a cross-sectional area of about 12.5, so we expect a little over 60,000 psi for our samples if they were well hydrated. We got another one that's really sloped at the top. It's pretty much would invalidate the test. We're going to test it anyway, see how it performs.
Camera still on.
Yeah. Still good. All right, this is our third sample, 0 to 1 inch, 1.5 inch slum. Again, we should get a little over 60,000 if it had good homogeneous mixture. Again, we're doing 3 and averaging them because they mixed them in a wheelbarrow. A little hard to get a really good homogeneous mixture. All right, 52,648, a little low because it did break off right where the corner was high. So in reality, that would actually validate the test. That would not be a sample we'd normally test.
Real good, so should be pretty
All right, now we're going to do our 6 to 9 inch.
Actual is 8.
Our actual slump was 8 inches, and they actually look pretty good as far as parallel top to the bottom.
And good.
And they're nice and smooth. Got all the detail. Ricochets it up there pretty good.
Huh?
Ricochets it pretty good. Again, the reason it takes so long to build up is because we're squishing those rubber pads. The concrete itself is not very compressible. So once we've squished those rubber pads, then it tends to go up really fast. Okay. We can see 45,896. So the concrete, we had a slump of 8, so the cement was diluted from so much water, and it gave us a lower value. Typically, we do that in case we need to do molding of thin wall sections or casting. We'll sacrifice a little bit of strength for moldability.
Or if it's getting pumped. Or if it's getting pumped, if they're pumping it.
Or if they're getting pumped, if they're pumping it. All right, here's our sample number 2, 8-inch slump. Typically, the 6 to 9 inch slump, usually they're a little bit more consistent, a little easier to mix it in the well barrel and get it homogeneous. We'll see how these 2 samples look when we're done here. And we got 46,600 something. I hit the button too soon, but hopefully you can see it in the recording. Real close to the 45,000 we got on the previous one. All right, our third one, again, 8-inch slump. The target was 6 to 9. All right, 48,924. So just a little higher than the other 2, but real close to each other.